Alright, we'll continue with another example, and this one we'll have to build our equation. So a farmer is constructing a rectangular fence in an open field that contains cows. There are 120 meters of fencing. Write the quadratic function that models the rectangular region and use it to determine the maximum area of the enclosed region. So again, very similar to the last type of questions, except now you have to come up with the equation yourself to use, and then continue on as the other couple of examples that we've done. So first, to build the equation, we're asked to find the maximum area. So area is width times the length. Now we don't know what the width is, so we'll just call it a variable. I would say x. So step one, identify which variable is the width. Now for the length, we have to, I guess, think about this for a moment. We only have 120 meters of fencing in total. So we got 120 meters in total. Our length can only be what's left over when we take away our width. So you have a length here and a length there. The width will be, well, whatever x is here, it's also there. So your length of your fencing is 120. Subtract the width that you're using, so twice the width. Now, when constructing a fence in an open field, length of the fencing is used when the first width and length sides are constructed. You also need to keep in mind that what we have written here stands for twice the length, so it's all the length that's used. So how much will one side be? Well, it would be half this amount, so you divide it by 2, or you would have 60 subtract x, because half the fencing is used to put the width and length in, so therefore it only leaves you the other half remaining. So here, so half of the fencing is used when constructing the first width and length. And using width and length expressions, develop the area function in standard form. Right? So the area is our width, x, times our length, 60 subtract x. X times 60, 60x. X times x, negative x squared. We would expect that because we're told to get a maximum. So the a value has to be negative. Now if we want to find whatever the maximum width and length are, or area, we'll have to solve this equation now. Alright, short sketch will help us picture the graph. We know it should be a maximum. Our area is here, and our width will be here. That's what our x values represent. Our y-intercept is 0 because there is no plain number here. There's no constant term. So the graph will come up, come down, and we want to find this maximum area. And to do so now, same as the other questions, we need to find the axis of symmetry, and we'll use that to find the maximum area. Okay, so we applied our axis of symmetry formula and found that the width is 30 meters. And then the maximum area, we'll put 30 back into the area equation. And filling in the numbers, we find out that the maximum area is 900 meters squared.